Today, we're going to talk about a new topic. So last week, we've studied functions and input-output, and etc. So today, we're going to study loop. So loop means you have a MATLAB code. Okay, you're going to repeat some part of it many times. So previously we said replace that repeated section using you can use MATLAB function. So by frequently call them. So in fact you can also use loops. Okay, so loops is let you repeat a part of the MATLAB codes. And we have two different kind of loop. One is for loop, one is while loop. So I'm going to talk about for loop first. So for loop, the syntax is like that. Okay? So once you write for, you must have an end. So for and end is a pair. Okay? So so when you write for loop followed by a counter variable, this counter variable basically you can define a name that you like. For example, I put I here as a counter variable. Okay, so then I assign I to a vector. For example, 1, 2, 3. Okay. So then the commands can be I plus 2. Okay? So the end. So this is how MATLAB will run this for loop. Is when the counter variable I, okay, first take the first element, which is 1. Okay? And then we run this command. So the next time, this counter variable will take the second element. So we'll take 2, and then repeat this command. And then third time, this counter variable going to take the last element, and then repeat these commands. So each time of this repetition is called an iteration. Okay, so in this for loop, how many iterations in my example? I have 3, right? So the number of iteration depends on the number of elements in this vector. Okay, all right. So now I change my MATLAB codes. Now it becomes, for example, instead is 1, 3. Okay, then how many iterations you're going to have in this for loop? 2, right? So the number of elements in this vector decide the number of iterations you're going to have. So this is for loop. So we see an example. So this is an easy example. So the counter variable is called counter. And it was assigned by a vector from 1 to 11, step 2. So this is equivalent to say you have 1, 3, 5, 7, 9, 11. So how many elements you have? You have 6 elements. So you're going to have 6 iterations. So for each iteration, what you're going to do here is using fprintf, you print out each of the counter. So for example, this counter is just this counter. Okay? So when this counter, for the first iteration, it takes value 1. So when you print out 1. And then the second iteration, the counter take value 3, and then you print out 3, and so on. Okay, so I'm going to demonstrate to you this example. This is a for loop example. Okay, so to make you visualize better, I placed the pause 1 second. So it's basically just print out this all the elements in this vector. Okay. So any questions so far? Oh, good. So this is for loop. So for loop is very easy to understand, and normally we prefer we like to use for loop. The reason is you know exactly the number of iterations you're going to have, so you can control it. Okay. So the second type is called while loop. This while loop is different from for loop, not just because of the name. Okay. So while loop, the syntax is given when you write while and then you have end. This while loop, instead of giving you a number of iterations, in while loop you don't have the number of iterations. You don't know the number of iterations. Okay? The while loop followed by a condition. So this condition is like a relational operator mixed with logical operator, ask you to compare something. Okay, so the while this while loop followed by a condition is saying if this condition is satisfied, then we do this command. Otherwise, if it's not satisfied, we just don't do this loop. Okay, so this is a while loop. And the condition is like if statement. So this while loop, when you write while loop condition, you're gonna pay attention. This condition sometimes cause some trouble. Okay. So now we see a few examples of while loop. First example. So this example is a counting down example. Okay, so giving you 5 assigned to n, and then you use a while loop. So you see this n now is 5. Okay, so it's saying if n greater than 1, so 5 is greater than 1, so you display n, which is 5, and right after your display, you deduct 1 from n. So now n becomes 4. Okay? So you repeat. Is 4 greater than 1? Yes, it is satisfied. And then the next time you display 4. And then this n now becomes 4. 4 minus 1 is 3. So by each iteration, n will deduct 1. So you are gradually print out a decreasing order. It's a counting down example. Okay, so this is an easy example I can show you here. So the last one is not displayed because it doesn't satisfy this condition. Okay, when it becomes 1, 1 is not greater than 1, so it's automatically skip that part and end. Okay. Any question on this example? Oh, good. So then the next example, actually, this is one example. This example has some problem. Okay, I'm going to demonstrate to you and explain why it has some problem. So let's first see the first while loop. We have a 2 while loop here. Okay, first while loop asks you input something, input a number, and then test whether it's equals to 0 or not. If it's equal to 0, you display, and then you repeat this input. Okay, you repeat this iteration. And then once you input a non-zero number, if you input a non-zero number, this condition is not satisfied. So what are you going to do? So MATLAB will go on, will skip the first while loop, go to the second one. So when you go to the second one, you see the second one has some problem. Is the condition is 1 equals to 1. When you're using while loop, you're followed by a condition. This condition is always true. Okay, this always true condition will have a bad consequence. Is you will have an infinite loop. Okay, if you have a condition always true, then you're going to have infinite iteration. So MATLAB was stuck there. So I'm going to demonstrate you this example. This example is the same while loop I talked about. Okay, first is asking you to enter a number. So if I enter 0, and it just display and ask you re-enter. Okay, if I keep enter 0, it always satisfies that condition, and then it keep asking you. Now I enter a non-zero. If you enter a non-zero, it skip the first while loop and go to the second one. As I said, the second one, the condition has some problem. Okay, always true condition. So you will end up have an infinite loop. Okay. So this infinite loop is keep displaying, keep running. So if you cannot force it stop, it won't stop. That's because this while loop, the condition is always true condition. So normally you don't set this kind of condition. This is a bad condition. So when you made a while loop, you get stuck. How do you do it? You use Control-C to break it. Okay? So there you break it. So this is while loop. So any question about while loop? So while loop is it's not so safe compared to for loop. And the main difference between for loop, while loop is for loop, you know exactly the number of iteration, and while loop, you don't know. It's just a condition. And that condition, you cannot set an always true condition. Okay? And you also, when you set a condition, that condition should be, update from each iteration. So, sorry. Let's see another example. This example is very easy. We repeat this example multiple times. It's saying the triangle, okay? Input one side, input the other side, and ask you calculate the opposite side. So basically, input 1 square plus input 2 square, take square root, will be the length. So we took this example last lecture as well. We use the if statement. It's saying if your input, one of the input is negative, then print out error and exit. That was the last lecture. And this lecture is to saying if this is 2 input. If this input is negative, then ask you to input another value until your input is positive. Okay? So this is using a while loop to rewrite the previous example. So this is another example I'm going to show you using while loop. And the while loop, this example could also have some problem. Okay? This example is saying, so you input a certain number to count down. For example, you input 5, and 5 assigned to A, and if A is non-zero, you display A, and every time you deduct 1 from A. So it's count down. It will be 5, 4, 3, 2, 1. Okay? Let me show you here. The same example, huh? So for example, I equal 5. I put 5, and then it's naturally come down. Okay? So what happens? What happens if I input not an integer, 3.5, for example? So 3.5, every time minus 1 is going to be 2.5, 1.5, 0.5, minus 0.5. So this condition in this while loop, you're gonna always satisfy this condition. So then it becomes infinite loop again, right? This is because this condition has some problem. Okay? So what can we do? Imagine if your input can be negative and can be decimals. What do you do? So what you can do is when you input a value, no matter what is integer or non-integer, you put a floor. So floor is a built-in function, is get the closest integer, okay, which is less than a. And even better, you can put an ABS here. Sorry. So you can put ABS here. You know, have you ever tried ABS? Yeah. Okay, absolute value. So you just put absolute value and floor A, and you force this input is an integer and positive. And then when it's positive, and then just display. So this is my correction. Of course, you may have multiple corrections. Okay. So I don't have this example. Sorry. So let me change here. So let's say ABS. Okay, and while a integer greater than 0. Okay, sorry. Display. Sorry, AINT. I'm gonna manually update this. I replace A by the new floor and ABS. Okay. That's a small example just to demonstrate you when you use while loop. There's many conditions you have to really play with while loop cautiously. And here, this is same example. You can also use for loop because once you get this integer a, positive integer, you can just from integer count down directly to 1 with the step -1. So it's the same example, just different way of doing it. And now we show you there's something wrong with this code, and I give you 1 minute. You read this MATLAB code and you tell me where is the mistake. Okay, so who can point out where's the mistake? There's quite a few mistakes. You can fix it. Yeah, so because that condition is always true, right? You didn't really, in the iteration, you didn't really update this x, right? It's always true condition, right? So how do you change it? Is there any idea of revising this part? You mean x equals? I can't hear. So that means x naturally increase in each iteration. Is it what you mean? Yeah.
We need to set our counter in here. We need to set our counter. So in the loop, the counter does not increase to get to the function.
So how do you increase that counter then? Yeah, n is 1 point, okay? Because each iteration you have to update n, okay? So each iteration you have to update n. This is 1 point. Another point is x, okay? So this x first assign minus pi here. So if you don't update x, this is always true condition. You're gonna always repeat this iteration. So normally you also update x. For example, every time you increase, let x increase from minus pi. Every iteration increase 0.1 and increase until this condition is not satisfied. Okay, so every iteration, okay, you're gonna calculate this absolute value of cosine of x and assign to y, n, okay? And then for each iteration, n naturally increase 1. And then at the end, so you get a vector of y. So when you plot, you should remove this. If you say plot y, bracket n, that means you only plot the last one, okay? Only one value, but you want plot the entire y. Okay, so this is the something wrong with this code and how we fix it. And a quick example, this is a quick example, is a wave energy converter. Actually, this wave energy converter is something you use to generate energy by placing them into, for example, river or ocean. So it looks like a connected train. Okay, so this big pipe will floating along the wave. So while they are floating, this connection will generate energies. So this is this example. In fact, because the wave, we can approximate use sine-Taylor series. So this is, again, we went back the sine-Taylor series example. This saying sine x can be rewritten as a Taylor series expansion of this entire thing, okay, with item n starts from 0 to infinity. So you are calculating this. But in reality, you take first few terms. This example has been popped out in our class. We have been repeating this example quite a few times. So you take multiple terms. The more you take, the better approximation. Last lecture, we said you can make a MATLAB function to handle this sine-Taylor expansion. Okay, that's what we did in last lecture. So last lecture, you're given x is from minus pi to pi radians, okay, with step 0.1. And so what you do is you call sine-Taylor function with input x and n. N is from 0, 1 until 5, the first 6 terms. And then you sum them together. So now, we look at this part. This is, we are building function, and we just write the entire line, okay, all sum them up. So in this lecture, since we studied the loop, So what we can do is we can replace this part with loop. So if you know exact the number of iteration, which kind of loop you're going to use? For loop, okay? So let's see this example. How this MATLAB codes still x is from -pi to pi, and n max is the number of Taylor series terms you're gonna have. So we ask you to input the maximum term. This we use if statement is saying if this n max is less than 0, then we set to 0. So if 0, 0 is going to be 1. Okay. So nevertheless, we go on. So we first call sine Taylor function with x and n equals 0, the first term. And we assign the first Taylor term to this variable called sine approx. Okay? And then since you know the number of iterations, so for the rest of n, is from n to n max, you can make a for loop. Okay? This is a for loop. So when you make a for loop, you want to add them all together. So what do? You use the initial variable sine approx plus this function, sine Taylor function, with x and n. For example, n equals 1, so this is going to be 1. Sine Taylor x, n equals 1. And plus sine approx. Sine approx you initialize is actually sine x is 0, the first Taylor term. So it becomes first Taylor term plus second Taylor term. This summation you reassign to sine approx. So sine approx at the beginning is first Taylor term and now become the sum of first two Taylor term. And then you go to next iteration, now n becomes 2. So here it becomes 2. So the third Taylor term. And now sine approx, because of the previous iteration, sine approx is already the first two Taylor term sum. And then now you sum anew the third Taylor term. So in such a way, in such an iteration way, okay, you summed all these 6 terms all together. Okay, so this is how we make a for loop for this sine Taylor expansion. Okay, any question about it? Okay, so when you use for loop, while loop, sometimes we also put break command. What is talking about break? It's very easy to understand. Is, for example, you have a loop here, and you use break. So that means MATLAB will stop this loop and exit. Okay? So we'll stop this loop and exit. Imagine you have a multiple loop, and inside you use break. So it depends on where it is. So if you use this way, so break will only exit from the single loop. Okay, only from this loop. So this is a break command. Now we see an example, break example, okay? I give you 1 minute to read this example. Okay, this example is saying, giving you a text file. Okay, I take an example. For example, debris.txt. What I have is 1, 2, 3, 2, 3, 4. Is a TXT file, 2 lines. Okay, the first line is data. Okay, second line is also a set of data. So now this example is to telling you open that file, read from that TXT file all the data. Until you reach the end of the file, you can't read any longer, you break it. You exit from while loop. Okay? So now we see this example. So this file name and open this file, okay? The mode is read. So n equals 1 line counter. So it's pointing the first line, okay? So while 1 end. This is infinite loop. But you have a break command inside, so it's okay. So first you use fgetL. From this file, you get a line. So at the beginning, you will get the first line. Okay? You go in this file, and MATLAB will read the first line. And then assign to TMP. So TMP here, as I mentioned, fgetL, when it reads a single line, it treats them as a string, okay, with the space in between. This is string, okay? And then you say use if statement. If what you have what MATLAB read, TMP, this variable, is that equals to -1. This is because fgetL has a special thing is if you reach to the end. For example, if you're reading the last line after 2, 3, 4, the last line is empty line, is the end of the file. So fgetL will return -1. Okay? This is the speciality of fgetL. So here is to saying what you read, is that equals to -1? If it's -1, that means you reach the end of the file. You use break to exit. Okay? However, if it's not the end of the file, at what we said is the first line, so you use a string to number because what you read is string. And the string to number, convert them to number and assign to this data. This data is a matrix. The line counter, line number is 1 here at the beginning. And this is a whole column. Okay, and the line counter increase. And then you go back. So you do the second iteration. Second iteration is fgetL again. So fgetL it naturally go to the second line and read the second line. So then you're repeating until you go to the end of the file. So when fgetL read the end of the file, it will return -1, and then it will break it. Okay, so this is the entire example, is to tell you read a file, and when you reach to the end, and you exit from the while loop. Okay, any question about it? So you have break, you have continue. Continue command is to saying what? Continuing is different from break in the way is if you have a loop here, you say continue. So that means you're going to skip the rest of the part, start the next new iteration. Okay? So it's, let's understand from this example. Let's say -1 to 1. Okay? So x is from -1 to 1. So what is x? X is going to be -1, 0, and 1. Okay? It's a vector. And the y, assign the same size. This is x. And then y assign the same size of x, but with all 0. This is called pre-allocation. You pre-create a y, and then you update each element. So then you use for loop. So from 1 to length of x, x is 3, length is 3. So 1 to 3. And then you calculate y. Each element is just 1 over x. minus 1, 1 over minus 1 is minus 1. So you update here with minus 1. And the 1 is 1 over 1. You update here 1. How about this one? 1 over x here, 1 over 0. It becomes 1 over 0. So this point, you don't want to do it because 1 over 0 is infinity. So how do you do it? You use continue at that point. So continue means skip this point, go to next point. Okay? So this is what you add. If x is 0, so we continue. Continue means you don't really do what followed. Okay? You go to the next new iteration, means then you do the next operation, 1 over 1. You skip this point. That is what continue means. Okay? This is quite useful, this command. This command, why it's useful is actually is giving in this example. Now, still debris TXT, but with text. So that means what? For example, here is what you get. Now, I give you a file, text file, and ask you to read from the file using MATLAB codes. So you observe this text file. It has a multiple line of numbers, and in between you have an empty line. And you also have text, something quite mixed. So this data file was mixed with text, mixed with empty line. So they ask you to write a MATLAB code to read from this mixed data file, but you only read that data part. If it's empty line, you skip it. If it's text, you skip it. So this is the idea of this example. So how do we do it? We use continue. Okay. So still, file name, open this file, and the mode is read. And still the same example, line counter y1 and fgetL to read. Okay, for example, is 1, 2, 3, and empty line, and then 2, 3, 4. Okay, so you have a empty line here, or can be some text. Okay, so what you're gonna do is you read this line, and then exit. Okay, so when you use fgetL, you get the first line. As I said, you can directly use a string to number to convert this string to a number. And the most important thing is here, you use a built-in function called isEmpty. So isEmpty depends on this variable. Okay, so when you read an empty line or text, when you use fgetL, read an empty line or text, it gives TMP, and then you use string to number, it's gonna be an empty set here. Okay, if you use string to number, it will give you an empty set. So then you say, is it empty? If it's empty, we continue, means we skip this line. We go to next line. Okay, so this is the major part of telling you, if you read the text, you read empty line, you skip it. And you read the next line. The rest are the same from how to read the data is the same from the previous example. So this is continue. And the last topic I want to mention is nested loop. So for example, we have two for loop nest together. Okay? So to understand this nested loop, I just take a simple example. X is from 1 to 2, and Y is from 1 to 2. So what it will work is from 1 to 2 is 1, 2, okay? Here is also 1, 2. So at the beginning, X will take 1. When X take 1, it go to the inner loop. And the Y will take 1, and then you print out y times x. What do you have? You have 1. And then you keep this loop. The second time, y is 2, okay? And x is still 1, so what you print out is 2. And then you finish this inner loop and print out new line, okay? So then you will start printing out here. And then now you go back to outer loop. X is 2 here, okay? And how about y? Y, you enumerate 1, 2. Again, when y is 1, you get 2. When y is 2, you get 4. And then print out new line. I can demonstrate you this example. First, I demonstrate you the previous example of reading from the debris data with text. So this is basically, you can compare this is the originally text file, and here is the data. So because you skipped, you use continue command, skipped all the text and empty lines from the previous example. And this example, I can just type in for y from also to 2 and fprintf. X multiply y. Okay, so you have end the inner loop and fprintf a new line. So this is exactly what you print out. Okay, so this is when you nest loop altogether. So we keep the last example for next class. So I think I'm finishing this class now, and see you